What if the function is below the x-axis? So how do we deal with that? So now remember, area is like length. Always positive. So in this case, say this is A, that's B, right? And I want to find this area right here. So how would I find that area? Well, in this case, when it's below the x-axis, it's going to be a negative of the area between the curve and x-axis. So in this case, you would write it like this. So yes, I know I'm kind of contradicting myself. The area is going to be negative. And I did say areas like length is always positive, but the thing is that the integral itself represents area, but when it's below the x-axis, you make it a negative value. So the definite integral will have a negative value when below x-axis. That's how you treat that. And just the negative of the integral of f of x dx. And a way you can kind of compartmentalize all this, it's going to be, the sum of all areas above x-axis minus the sum of all areas below the x-axis. So say, for example, we have this curve here where portions above the x-axis, portions below the x-axis. So then you would just write this as simply, if this is A and this is B, the integral of A to B of f of x dx is simply going to be 3 minus 8, or negative 5. Let's keep moving. So say, for example, we have y equals 2, f of x equals 2. And I'm going from 1 to 4. So, I mean, that's pretty easy. Your width here is 3, your height's 2. So you're simply doing 3 times 2, which of course is 6. Now what if I have negative 2? Also from 1 to 4. Well, again, that's still 3, and that's still 2, but because it's below the x-axis, we're going to say the area is negative 6. Or you do negative, the difference, your y value times 4 minus 1. So really we can kind of see what's happening here. Like, for example, what if I want to go from 1 to 11 of 2 dx? Well, I just take the y, I just take 2 and just do this. Because again, I'm still graphing y equals 2, but now I'm going from 1 to 11, right? So that's going to be 20. Or what if I do 1 to 11 of 5 dx? Well, 5 is the height. The difference is 11 minus 1. So I get 50 for that area. Question in the chat. No, so I know I kind of contradicted myself. Someone's asking, I thought that I just said the area cannot be negative. Area in general is a positive value, right? It's just that the integral will be a negative 1 times the area. Think of it that way. I probably shouldn't have said that. The bottom line is that the value of the definite integral will be negative if your curve is below the x-axis. Just realize that. I think that's just the best way to think about it. Now here, again, you have y equals -2, right? So you do -2 times 4 minus 1. So of course we got -6, just like we got earlier. So what this means is that if you take the integral of a constant, you take your constant, multiply by b minus a. That'll be the value of that definite integral. And remember we said that all continuous functions were integrable and even some discontinuous ones. Well, if a function with a bounded y values has a finite number of discontinuities, I'll draw a picture to know what I mean by that. And but continuous everywhere else, so apparently it could be integrable. So for example, like we've seen this before. I'm not sure if you guys remember. The graph looks like this. You go from -3 to 4. Okay. So if we think about it, that's like saying y equals -1 here. That's like saying y equals 1. If you guys forgot, the absolute of x over x can be written as a piecewise function with 1 and -1. If x is bigger than 0, or with the equal sign next to either one. So in this case, you're looking at this area, but we're going to say that's -3 because it's below the x-axis. And this will say is 4. So think about it geometrically. So somebody doing -3 plus 4, which is 1. So you can think of it like that. Or 4 minus 3. The sum of the areas above minus the sum of the areas below. But you could make the area below negative and then just add them up as well. Same thing. So the bottom line is that any region below the x-axis has a negative value for the integral, any region above has a positive value, and you combine those areas. Or you can take the regions above minus the area of the regions below. Same thing. Okay, we're at the home stretch here, so we get these notes done with. Something called numerical integration, and I can't believe I don't have my TI emulator working. It's frustrating. I need to get that taken care of ASAP. Okay, I will email my department chair to get a license. Yeah, that's gonna make this a little tricky, but we'll do my best. I'll kind of walk you guys through it, and then I'll have you guys type in the chat. So there's a function in the calculator that does integrals for you. This is in the TI-84. To locate it, you hit alpha, then window. And I think it's option 3. And actually, I am going to have to grab some batteries for one of my calculators out of batteries here. Give me 1 second. Okay, here we go. Let me have it open. Don't look like it. Okay. That's one nice thing about having a home office. Everything is here. So go ahead and see if you can access that first. Hit alpha window. You should see something that's called FNInt. And it should show up kind of like this. With these little like boxes. But hold on, let me see if I can open this. Okay. Oh, come on. Sorry about that. Just getting these batteries in here. Okay. Cool. This all's working okay. So again, hit alpha window. That's wrong. It's option 4. Hit FNInt. And in fact, it looks like this. And there's a little parentheses here. There's a D and another box. So what we're going to do is we're going to evaluate this one. Now, sin x is kind of funky. I mean, it's not. We know how the curve looks. But when you're going from 0 to pi, it looks like this. Here's 0 and here's pi. And it's not necessarily a semicircle. It's actually kind of a weird shape. I think there's actually I can't remember. It might be a formal formula, but I don't know what it is exactly. So we're going to let the calculator do this for us. So what you do is you tell the calculator, hey, let me plug in 0 here, and pi here, and sin x here, and dx here. That's what we do. And you'll do the calculator. Now make sure you gotta be in radian mode, by the way. You gotta be in radian mode. So we go 0, pi, sin x, dx. And my mode is radian. Hit enter. And what I like to do is that if you've already done this, go ahead and type in the chat what you got. So again, hit alpha window in the calculator, and then option 4, and then type in 0 pi sin x dx. Make sure you're in radian mode. We'll see what the responses are appearing. Good. You guys are getting it. So the answer is just 2. Yes, the answer is 2. So there we go. Not too bad. Now let's do this again, a different integral, but we're not going to use a calculator here. So one thing you could do is you could actually factor your integrand, if it's possible, factor, and x minus 2 in the bottom. Now you got to factor out a negative. You could factor a negative from 2 minus x, make it that. So it's -2 minus x. So we have that. We have that. Okay. So what I just did was I simplified this expression here. After I simplified it, I got a new equation. I graphed it. You know, that's just a linear function. And went from -5 to 3. Okay. So now you find your areas, which shouldn't be too hard. So what I want you guys to do again, and we'll see what you guys get in the chat. Find me this area. We'll call this area 1. Find me this area. We'll call this area 2. And then give me the combined area. So what I want you to do is tell me what the combined area will be. And remember, area 2 is going to be negative because it's below the x-axis. So what will the combined area be? You can put in the chat. So you find the area of one triangle and the area of another triangle. Remember, area of a triangle is 1/2 times base times height. Okay. So I'm getting a couple inches are correct. So the answer is -8. So the first area is 1/2 times your base, which is 3, and your height, which is also 3. So that's 4.5. Here you're doing 1/2. Your base here is 5, and that's also 5. But because it's pointing down, we're going to make that negative. So it comes -12.5. And when you combine them, you get -8. So combined area should be -8 here. So sometimes you have to look for factoring too. Okay. And last example, the one in the notes here. Then I think what I'll do is I'll talk about the worksheet a little bit and the textbook problems. I'm going to go light on the textbook problems, but I do want you guys doing the worksheet. Question in the chat. Could we have calculated the integral by hand if the function wasn't linear? Great question. Great question, Catherine. Yes, you can. You won't be able to do it geometrically necessarily. Like, what if your function was like cubic or a square root? Then you're going to have to do a technique called anti-differentiation or find antiderivative. And there's actually a process to do that, and that's what we're going to talk about next week. We're not going to get to that this week. And that's actually part of the fundamental theorem of calculus. We'll get there, but not today and not this week. But yes, I'll show you how to do ones that are not linear. But for now, we keep things simple, right? Here's one last example. the tank is being filled at a constant rate of 4.5 gallons of liquid per second. Okay. Sketch the graph of the rate of change. Okay. So it's the rate of change, liquids per second. So this is how much fluid is coming in, right, into the tank. And then once you express the amount of liquid entering the tank during the first minute of filling as a definite integral and evaluate the integral using the definite integral of a constant function. Okay, let me explain what all that means. So the rate of change, remember that's gallons per second. That's what's given to us, right? Gallons per second, and the time's also in seconds. And so basically it's like saying y equals 4.5, because that's a constant. Now, we're doing this for the first minute. However, we're having this in seconds. So you want to treat this as 60 seconds. So from 0 to 60. Okay, so I want that area. Well, remember we talked about this before, that what's really going on here is that you're taking these units of the y value times the units of the x value, and so it's going to get us gallons, right? It's going to get us volume. But you're integrating from 0 to 60, because remember you got to keep those units the same, seconds for time, gallons per second for the rate of change of liquid. So you're going from 0 to 60 of 4.5 dt. I mean, you could use x if you wanted to, but I feel like using time here. We'll call it t, by the way. Of course, it's y right here. You integrate that. It's a constant, so it's just 4.5 times the difference of your left and right endpoints, or your interval, width of your interval, which is 60. And so you get 270 gallons. So that's the advantage of integrals, is that it helps us find the total amount of something that's done, or more specifically, the net change or net amount. So like initially had no volume in the tank. After 1 minute or 60 seconds, now you got 270 gallons because you took the integral. I mean, I know it's simple. You have a rate, but when your rates are not constant, in fact, when you can express a rate as a very interesting or very funky equation, then we need to have some process, and so that's where calculus comes into play. And to Catherine's question, like, what do you do when it's not linear? Like, what if your rate of change is expressed as a function, it's not linear? I will talk about that next week. I'll show you how to do that. Okay, so this is good, actually. I'm actually really quite impressed that we got this done. And I still watched part of the inauguration. If you did watch it, I did. And so even took a break too. So, and we still got 15 minutes left. So let's actually talk a little about the worksheet. Let me show you how the worksheet goes. Let's see, you get more comfortable with, like, you know, segmentation, Riemann sums, stuff like that. And I'll keep the video going so you have that as recording. So there's 8 problems here. It's not too bad. So here you're asked to evaluate each sum. So for example, k equals 1 and you have 18k. So it's simply going to be 18 times 1 plus 18 times 2 plus dot, dot, dot until you get 18 times n. Not sure what the answer key is looking for. Yeah, I don't know if that's what I want you guys to do. You know what, let's ignore 1, 2, 3, 4. That's using something called geometric series, or sorry, arithmetic series. we didn't really cover that, I think, in second semester pre-cal last year because of the pandemic. So let's just chop those off. Let's chop off 1, 2, 3, 4. I don't think I really want you guys doing that. I didn't know that's what they're going after. However, I think the other ones are pretty good. And actually, I'll just do them with you guys, just so there's no work to do for homework. In fact, you don't even have to turn it in, just follow along. So they want the limit as n approaches infinity of this. Now remember, this is a definite integral. That's what this is. Both of these are. So you just do the integral. And we're not told what the limit is, so you just write, you don't put limits in this case. It's going to be 2 over x. And k is a constant, so, no, sorry. Wait 1 sec. Hold on. Maybe this worksheet's just bad. Yeah, this is just a bad worksheet. Okay. Give me 1 sec here, guys. Okay, let's just do 7 and 8. Okay. Okay, Epic failed this worksheet. I wasn't careful when I downloaded this one. Okay, let's just do 7 and 8. This we can do. Okay. Find the area of the curve for the function for that interval and assume n goes towards infinity. So you write this as a definite integral. There we go, from 0 to 3. Of 3x plus 3 dx. Well, one way you could think of this is that 3x plus 3 crosses the y-axis at 3. Let me draw it again. This is going to be more in line, I think, what we're doing tomorrow. So I'm glad actually I didn't make you guys do this worksheet. And if I plug 3 in, I think it goes all the way to 12. So find this area, right? Okay. So you just find that area. I mean, it's not that hard. This is going to be area of 9. And both these are above the x-axis. That's going to be 1/2 times your base, which is 3, times your height, which is 9. So you get 13.5 plus 9, so you get 22.5. There you go. Boom, 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 boom. Very simple. So that's number 7. So the next one here. Yeah, that one you can't do yet either because I haven't taught you guys how to do this of nonlinear functions. So yeah, I think I just gave you guys just a crappy worksheet. Let's not worry about it. Let me tell you what homework's going to be. So homework will be some textbook problems on what we just did. So I'll make sure you guys have enough practice. And what I'll try to do maybe is I'll say, hey, these problems deal with this example in notes. This problem deals with this example in notes, just so you know where to look. Actually, I can probably stop my recording right now.